Hello everyone, we're going to be working on the 80s in Unit Pack 4. You will need your periodic table today as we're going along. So today, or I shouldn't say today, this week, we're going to be getting you ready for something that most of you would consider to be the ultimate in chemistry, and that would be getting a bunch of bottles of chemicals, mixing them together, and things happening with them. So this whole week is dedicated to getting a bunch of bottles, mixing the chemicals together, a chemical reaction occurs, and then we'll try to figure out what is in each of these bottles. So you'll be performing a lab with 6 different ionic solutions. You'll mix those solutions together. Some of the mixtures will result in a chemical reaction and some will not. Your goal will be to figure out what solution is in each of the bottles and based on how they react with each other. Each ionic solution contains a positive ion known as a blank or a blank, and a negative ion known as a blank or a blank. So pause the video and see if you can fill in the blanks. Well, you can call it a cation or a metal ion, and you can call it an anion or a non-metal ion. Those would be your choices for that. So we talked about how things dissolve or dissociate in the past. We talked about the water molecule. So there's the oxygen. It's got a slightly negative charge. Here's the 2 hydrogens. They have a slightly positive charge. And how those positive charges will go around this negative chloride and it'll completely surround that chloride and then it'll pull it off the crystal. Then you'll have chloride ions floating around, and how the negative oxygen will do the exact same thing to the sodium right here. So if we look over here, we get all these negative oxygens attracted to that positive sodium, and that pulls it off the crystal. So we're going to take all these solutions where we have ions floating around inside the bottle. So we use the phase AQ, and we have talked about this already, to represent a solid dissolved in water. Aqueous or AQ means a solution, a solute dissolved in a solvent. So we have these particular solids right here, and we want to make these into solutions. So we want to dissociate them. And we've done this already earlier in the unit. So we got our lead 2 nitrate up on top. It's a solid. You throw in some water. It breaks apart right at the ion line. So this is a polyatomic ion, and this is a metal ion. So we get the lead 2 ion right there, aqueous, meaning dissolved in water. And to balance it out, we get 2 of these polyatomic ions called nitrate ions. And if we're going to put words to it, we'd say lead 2 nitrate dissociated into lead 2 ions and into nitrate ions. So now I want you to try it. So pause the video and see how you can do. Well, we're going to break this again right along ion lines. So we can have a metal ion here, and we can have our polyatomic ion here. So we got Ag. You probably have to go look on the periodic table to figure out what the charge is on Ag. That would be a 1 positive. Aq means it's dissolved in water. And then we get nitrate. That's a polyatomic ion. It's found on the back side of your periodic table, and that's a 1 negative. So if we're going to write this, we would say silver nitrate dissociated into silver ions and nitrate ions. Pause the video and try this problem. So in this problem, we're going to take it a little bit further. So where are we going to break it apart? We're going to break it apart at the metal ion and the polyatomic ion. So here we get 2 Na. We find sodium, which is element number 11. That's a 1 positive. That's an aqueous because it's dissolved in water. And then we're going to get 1 of the carbonates. So 1 CO3. And if you look at the back side of your periodic table at the polyatomic ions, its charge is a 2 negative, and we put AQ, which means it is dissolved in water. So this is really nothing new that we've taught you. So we're going to mix these solutions together and see if any chemistry will happen. How will you know if a reaction occurs? What could happen? Well, you could have some bubbles forming. You could have a color change. You could have energy released or absorbed. In other words, the solution can get warmer or colder. And we can get a precipitate. It precipitates when you take two solutions, two liquids, pour them together, and all of a sudden a solid forms from that. And I'll show you that on the next page. So these are all precipitates. So in this particular beaker, there was a solution, and then we're dumping another solution into it. And when those two solutions hit, then we get this yellow color that's right here. Same thing happens in the rest of these. They all had solutions in all these test tubes. And then with an eyedropper, hopefully you can see it right there in all of these, the eyedropper puts in another solution, and then all of a sudden a precipitate forms. So we got two solutions, two liquids, and those turn into a solid. That's what a precipitate is. So when you mix hydrochloric acid, you have hydrogen ions and chloride ions. And when you have sodium chloride solution, you have sodium ions and chloride ions. You're really mixing these four ions. So we're mixing these two ions with these two ions when we put them together in a test tube. We need to figure out which two ions of the four will react. We'll look primarily at the formation of a solid where there wasn't a solid before. And again, this is called a precipitate, or PPT for short. The question is, will hydrochloric acid and sodium chloride have a chemical reaction when they are mixed together? So make a guess right there. Will they have a chemical reaction when they're put together, or will they do nothing? What is your guess? So now we're actually going to figure this out. So breaking these apart, dissociating them just like we did before. So we break it apart between ions. So we get hydrogen ions, AQ. And then we get chloride ions. Again, looking at the periodic table to get the charges for these things. So that's what we have right there. And then we're going to break the sodium chloride apart. We're going to break it apart right at the ions again. So we got Na, 1 positive, AQ, and we have Cl, 1 minus, AQ. So that's what it would look like. This is a prettier version of what I just showed you. And the answer is nothing's going to happen because the ions are already in contact with chloride. So what do I mean by that? Well, nothing happened here when it's sitting in its bottle. It looked like a clear liquid. And nothing's happening here when this is sitting in its bottle. It looks like a clear liquid. So if anything was going to happen, they would have to swap partners. So this sodium would have to react with this chloride for a chemical reaction to occur. Or this hydrogen ion would have to react with this chloride for something to occur. Well, hydrogen reacting with chloride, that's that right there. And sodium reacting with chloride, that's that right there. So we would not expect a chemical reaction to occur in this place. So nothing would happen if we mixed these two solutions together. This is on the back side of your periodic table, so find this, and we're going to start using this chart as we're going along. So when we use this chart, we usually identify the negative ion. So like in the last problem, we would look at chloride. That was a negative ion for both of them. Then we come over here to the positive ion. So it says silver ions, lead ions, mercury ions, and copper ions. They all form precipitates, form solids. When these four ions come in contact with chloride ions, they form a precipitate. But we had H1 positive and we had Na1 positive. Those are part of this all others group. And it says it's soluble. Soluble means it does not form a solid, and it actually would dissolve or dissociate in a solution. So no solid would form there. So by using this table, we're able to figure out what chemical reactions would occur and which ones would not. So here we go. Here's our first little bit of work. So we have sodium phosphate right here and zinc sulfate. And we're going to mix those two bottles together, those two solutions together. So here's my sodium phosphate. I showed how it's broken apart right there. And now I have to do the exact same thing for the zinc. So break the zinc sulfate apart. So I break it apart right between the polyatomic ion and the metal ion. So I get Zn. I look on the periodic table to find its charge. It is a 2 positive charge. I look for SO4. It's a polyatomic ion. It's found on the backside of your periodic table. That's a 2 negative charge. Now, if a chemical reaction is to occur here, it's going to be between the sodium and the sulfate, or it's going to be between the zinc and the phosphate, because nothing's going on in this bottle, nothing's going on in this bottle. It's when we mix the two together that something could occur. So let's go through and try to figure this out. So let's find SO4. Don't have SO4. Here's SO4. So we found SO4, and it would be reacting with sodium. So we come over here, and we have this top. It says Ca2 positive, strontium ions, barium ions, silver ions, lead ions, mercury ions. All of those form precipitates. It says all others are soluble, which means they will not form a precipitate. So our combination is not this. These ions will remain floating around inside of the test tube. Nothing will occur with them. So now let's go down to phosphate and zinc, which is our other choice. So we find phosphate right down here. And we go over here and it says hydrogen, ammonia, lithium, sodium, potassium family. All of those are soluble, meaning it stays as a liquid. But we're mixing phosphate with zinc. Phosphate with zinc. So zinc would be part of this all others group, and there we get a precipitate. So our precipitate, according to this chart, again, we had Zn2 positive here, is the combination of the zinc ions with the phosphate ions. That's what we are finding out. So then we have to go a little bit further. So we're going to write, let me see what's on the next slide. It's not on the next slide, so we're going to come back to this slide. And so we're going to write this out. So we would go Zn2 positive AQ plus PO4 3 minus AQ. And I ran out of room on my board. Arrow, so the arrow is going to come down here because I don't have enough room on the top, are going to form into Zn PO4 solid. And now I need to balance the charges. So both of these numbers have 6 in common. I would need 3 of these zincs, and I would need 2 of these PO4s solid. So that would be what I would write out for the combination that forms a precipitate in this problem. And I'd have to go back here and balance it out by putting a 3 there and putting a 2 there. So if I mix those two bottles, these two bottles, we will get a chemical reaction in the form of a precipitate, and that precipitate, that solid that forms, is zinc phosphate. So now let's try the next one. So do the work here, see if you can figure it out, and then come back to me. All right, so I'm going to break this apart again at the polyatomic ion. So I get silver ions, AQ, and I get ClO3, and that's a 1 negative AQ. Again, this is found on the back of your periodic table as a polyatomic ion. The next one, I break apart again right between the two polyatomic ions. So that's going to be NH4. And I have 2 of them, so I'll put the 2 out in front, AQ, and that's a 1 positive. And then I get CO3, and that's going to be a 2 negative, and that's going to be an AQ. So if a chemical reaction is going to occur, it's going to occur with these 2, or with these 2. It's going to happen in one of those 2 cases, or maybe not at all. So let's look for ClO3. Here is ClO3. We come over here, it says all. So all positive ions are soluble. So our reaction is not this ammonia with the ClO3. So let me erase that part. You keep it on your paper. I'm just erasing mine, so it's a little bit easier to look at what's going on. So now let's look at this ClO3 3 here. So this was ClO3. Now we're looking for CO3. And here is CO3. And what was it reacting with? Silver ions. So right down here, we look in this box. Silver ions is not there, so it's part of the all others group, which means it forms a precipitate. So when carbonate ions and silver ions come in contact with each other, they make a precipitate. So now I write out the balanced equation. Ag, 1 positive, plus CO3, 2 minus, is going to equal, and now I got to balance out these charges. So it's going to be AgCO3. This has a 2 minus. This has a 1 positive. They have to add up to 0. So it's going to be Ag2CO3 solid. Put a 2 in front of the Ag to balance out the equation. And then I name it. So going back to earlier in the year, silver, and that's carbonate. And so that's the name is silver carbonate. And this C actually should probably be lowercase because that's how you'll see it in a book. So there is all the work that I just did. Feel free to pause the video and take a look at that if you need to do so. So pause the video and try to do this one on your own. And then I'll reveal what's going on. So in this problem, I'm just going to kind of show you the answers. So that's what we have. Break it apart. If we look at this using this chart, CrO4 is right here, and CrO4 with lead. So we go over here, here's lead, and it says forms a precipitate. So that's where I get all my information from. So again, pause the video, write down what you need to write down, check your answers. I'm hoping that you did this. All right, do this one on your own. Pause the video. So in this problem, we get potassium ions. Taking the charge right off the periodic table, you get hydroxide ions. Down here, we get magnesium ions. Again, get the charge right off the periodic table. And we get 2 chloride ions. So the chemical reaction, again, is going to occur. It's going to be if they swap partners. So let's look for this one first. The hydroxide and the magnesium. So here's hydroxide. I look right here. I'm looking for magnesium. Magnesium's not in that group. It says all others including magnesium. So there we go. That is a precipitate. So we found our precipitate. Let's look at the other one, though. That would be the potassium with the chloride. So let's go over here. Here's chloride. Potassium is not part of that top part, so it's part of that bottom part, and that says soluble. Soluble means it's going to dissolve in a solution. So that is not our precipitate. So now if we're going to write this out, we put in the first one Mg2 positive. I'm going to have to erase this so I have some room to write. And that's going to go with the Mg, or excuse me, the OH, 1 negative. Those 2 charges do not balance yet. So when I write this MgOH, I'm going to need 2 of these 1 negative ions to balance it out. So it means a 2 there. And I put a parentheses around it. And I call this magnesium hydroxide. All right, do this problem and I'll reveal the answer in a little bit. Pause the video. So with this problem, there's all the work. We look on our sheet, we see there's chloride and there's silver, so that combination forms a precipitate. We look for nitrate, NO3, here's nitrate, and it says all positive ions with nitrates are soluble. Pause the video, try this problem. Use the answer to this one. So in this instance, we have iodide. Here's iodide. And we have lead. So we go up here and there's lead. That says precipitate. Let's check out the nitrate. Here's the nitrate with the potassium, which would be part of this all group, and that's soluble. Pause the video, check your answers. And this would be bell work if you were in school, so you don't have to worry about that. So have a good day, and this information will be used in the labs that are coming up.